This video is Module 6, Data Link Layer in the Cisco Networking Academy Intro to Networks course. The purpose of the data link layer. The data link layer is responsible for communications between end devices, in-device network interface cards. It allows upper layer protocols to access the physical layer media and encapsulates layer 3 packets, both version 4 and version 6, into layer 2 frames. It also performs error detection and rejects corrupt frames. The IEEE 802 LAN-MAN standards are specific to the type of network, Ethernet, WLAN, WPAN, and so forth. The data link layer consists of two sublayers, the logical link control and the media access control, the LLC and the MAC. Don't get that confused with the MAC address. The LLC sublayer communicates between the networking software at the upper layers and the device hardware at the lower layers, and the MAC sublayer is responsible for data encapsulation and media access control. Here's a visual representation of the sublink of the data link sublayers. Packets exchanged between nodes may experience numerous data link layers and media transitions. At each hop along the path, a router performs four basic layer 2 functions. It accepts a frame from the network medium. It de-encapsulates the frame to expose the encapsulated packet, and it re-encapsulates the packet into a new frame. And then it forwards the new frame onto the medium of the next network segment. The data link layer protocols are defined by engineering organizations, the Institute for Electrical and Electronic Engineers, or the IEEE, the International Telecommunications Union, the ITU, the International Organizations for Standardization, the ISO, and the American National Standards Institute. And in most times, you're going to hear just the acronym IEEE, ITU, ISO, and ANSI. Next, we're going to take a look at topologies. We have the physical topology and the logical topology. There's two types. The physical topology shows physical connections and how the devices are interconnected. And then we have logical topology that identifies the virtual connections between devices using device interfaces and the IP addressing schemes. There are three common physical WAN topologies. We have point-to-point. That's the most simple and common. It consists of a permanent link between two endpoints. We have hub and spoke. That's similar to a star topology, where there's a central site and it's connected to branch sites through point-to-point links. And then we have a mesh. That provides a high availability, but it does require every end system to be connected to every other end system. On the point-to-point WAN topology, a physical point-to-point topologies directly connect two nodes together. The nodes may not share the media with other hosts. And because all frames on the media can only travel to or from the two nodes, point-to-point WAN protocols can be very simple. End devices on LANs are typically interconnected using a star or extended star topology. Star and extended star topologies are very easy to install, they're scalable, and they're easy to troubleshoot. And early Ethernet and legacy token ring technologies provide two additional topologies. Bus, that's all end systems are chained together and terminated on one end, and ring, each end system is connected to its respective neighbors to form a ring. You're not going to see bus topology very often, but there are some networks that are still out there that way. You're most likely going to see star topology or extended star topology. Half duplex communication only allows one device to send or receive at a time on a shared medium, and it's used on WLANs and legacy bus topologies with Ethernet hubs. And then we have full duplex communication. That allows both devices to transmit at the same time and receive those on a shared medium. And Ethernet switches operate in full duplex mode. When we're talking about contention-based access, all nodes operating in half duplex are competing for use of the medium. And some examples are carrier sense multiple access with collision detection, CSMA CD, that's used on legacy bus topology Ethernet. And then we have carrier sense multiple access with collision avoidance, that's CSMA CA, and that's used on wireless LANs. And you are going to need to know these two terms. Those are going to be on exams. And then we have controlled access, that's deterministic access where each node has its own time on the medium, and it's used on legacy networks such as Token Ring and ArcNet. The CSMA-CD is used by legacy Ethernet LANs. It operates in half duplex, and only one device sends or receives at a time. It uses a collision detection process to govern when a device can send and what happens if multiple devices send at the same time. And then we have CSMA, collision detection process. The devices transmitting simultaneously will result in a single collision on the shared media. The devices detect the collision, and then they wait a random period of time and retransmit the device data. The CSMA-CA is used by the IEEE 802.11 for WLANs. It operates in half duplex mode where only one device sends or receives at a time. It uses a collision avoidance process to govern when the device can send. And when transmitting, devices include the time duration needed for the transmission, and then other devices on the shared medium receive the time duration information, and then they know how long the medium will be unavailable. Let's take a look at data link frame. Data is encapsulated by the data link layer with a header and a trailer to form a frame. The header, the data, and the trailer, and those fields of the header and trailer vary according to the data link layer protocol, and the amount of control information carried within the frame varies according to access control information and the logical topology. Here we have a visual representation of the header, the packet, and the trailer, and then it's broken down with our frame starting, our addressing, the type, the control, our data is here, then we have error detection, and then we have our frame stop. The layer 2 addresses, it's also referred to as the physical address. It's contained in the frame header. It's used only for local delivery of a frame on the link, and it's updated by each device that forwards the frame. The logical topology and physical media determine the data link protocol, Ethernet, 802.11 wireless, 802.11 wireless, point-to-point, high-level data link control, or frame relay, and each protocol performs media access control for specified logical topologies. So what did we learn in this module? We learned about the OSI model layer 2. We learned about the data link layer being responsible for the network interface card to network interface card communications. We learned about the IEEE 802 LAN-MAN data link, 3 common types of physical WAN, half duplex communications, in-contention-based multi-access networks. We learned about examples of contention-based access methods. We also took a look at data link frame and that it has 3 parts, header, data, and trailer. The field frames included. We also looked at the data link addresses and they're known as the physical address. And then finally, that data link addresses are only used for link local delivery of frames. They do not get routed. These are the new terms that we covered in this module. I'm going to leave it up for a few seconds for you to pause the video and review these. And I hope you have a great day, and thank you for watching the videos.